Hello, this is David Harper of Bionic Turtle with an illustration of accrued interest and how we calculate accrued interest to get to the clean price of a bond. To understand the idea, consider a coupon-bearing bond. This could be a corporate bond or a treasury bond that pays coupons every 6 months. So it may be a coupon is paid on January 1st, for example. The holder of the bond will have to wait 6 months to July 1st to receive the next coupon. Now, buyer and seller may come together in the meantime to transact the bond, and typically they'll do that in some period in between the coupon payments. And they will transact this bond. The seller will sell the bond to the buyer at the full price or the invoice price, which necessarily needs to include the interest that's been accrued between this last coupon and the settlement date. So if we think about the time between the coupons, the seller of the bond's been holding the bond in this period here, and that interest accrues to the seller. Then the buyer's going to have the bond, and the interest in this segment here is going to accrue to the buyer. The calculation of accrued interest is somewhat intuitive. If we have a coupon payment here, that's this value or this value, we multiply it by the fractional number of days between the last coupon to the settlement. So for example, if the bond just happens to settle at the midpoint here, you can see that the seller would have held the bond for exactly half of the total period. So we would have this fraction would be 0.5. The number of days from the last coupon to settlement would be half of the total number of days between the coupon. This 0.5 would be multiplied by the coupon, and so the accrued interest would be exactly half of a coupon, which hopefully makes some sense here. Okay, so let me use an actual example with numbers. A lot of numbers here, but it's just one bond example. Assume the bond is priced at par, the yield is 4%, and it's an 8% coupon paid semi-annually. This is a typical assumption for us, and what it means is 8% times the par of 100 is $8. But that's annually, so a coupon is paid, a $4 coupon is paid every 6 months. A $4 coupon. Then I'm just going to assume that the last coupon conveniently paid on New Year's, January 1st, 2008. That means the next coupon pays on July 1st. And let's assume that the bond settles. Maybe I sell the bond to you today, which happens to be May 16th. So the settlement is obviously in between coupons. Now, if we were to do sort of a plain vanilla bond pricing problem like for a standardized financial exam, oftentimes we're really pricing the bond as if we're happen to be luckily right on a coupon date. So we might plug in something, assume something like 2 years to maturity, and I forgot to say, let's assume this bond matures in January 1st, 2010. So if we assume 2 years to maturity, we're really pricing the bond as if the settlement date were January 1st, 2 years from January 1st, 2008 to until January 1st, 2010. And so if we use 2 years as the time to maturity on the bond, and then we price the bond with these other assumptions, we might get a value like $107.62. Is that the price of the bond? Well, it's not the price of the bond today on the settlement date. That would be the price of the bond as of the last coupon day, January 1st. It's not today. It's actually in the past. Okay, if we did a full pricing exercise here, present value, on the settlement date, again, May 16th, we're between coupons. We can absolutely do that because the full price or the invoice price paid by the buyer to the seller, after all, does need to reflect the net present value of the cash flows. So if I want to do that correctly to get the full price, I need to, in my calculations here, include the right fractional period. So I won't do that detail here except to say that this calculation here reflects the fact that I have a fractional period or less than 6 month interval from my settlement to the next coupon. So if I do that correctly, I get a full or invoice price of $111.06. Now, that is going to include the accrued interest because as the buyer, I'm going to pay this amount. That amount is necessarily going to include the accrued interest that I owe to the seller. Again, that accrued interest being a function of the distance from the last coupon. So how would I get the accrued interest? Well, W here denotes the days to the next coupon. If my settlement is May 16th and the next coupon is July 1st, it happens to be 45 days. How many days are in the total coupon period or 6-month period? Between January 1st and July 1st, I have 180 days. That's half of a year, half of 360 days. This does depend on the day count convention. I'm using the 360-day day count convention. That won't necessarily be the case. It depends on the instrument. But I'm just keeping this convenient here. So what this means is we've had 45 days to the next coupon out of 180 days in the 6-month period between coupons. So we have 25% of the period to go to the next coupon. That means we have 75% of the period has already passed, and that is accrued interest to the seller. And so here the formula is pretty straightforward. It's the coupon, in this case $4, multiplied by 1 minus W. In this case, that's 1 minus 0.25, or 75%, which gets me $3. Hopefully this makes sense. If $4 is the coupon, and we only have 45 days to go in the period, that means 75% of the period has already elapsed. That means 75% of the $4 coupon has already been earned by the seller. It's accrued interest. It's $3. So finally, we can summarize the relationship here. Here's the full price, the invoice price, sometimes called the dirty price. It's what I, the buyer, pay to the seller. It's this $111.06. It includes $3 of accrued interest. I subtract the accrued interest from the full price to get what's called the clean price of the bond. Another way to look at this is the clean price plus the accrued interest equals the full price. So I hope that helps to illustrate this relationship. This is David Harper, the Bionic Turtle. Thanks for your time.